Well, the word trig, or trigonometric, which I suppose is even worse, is in the title for this lesson, and so some of you may already be scared. Try not to be. I'm hoping I can keep this fairly simple for us. This lesson is about evaluating limits that involve trig analytically. So we've done some of these before using a table or maybe using a graph, but doing them analytically requires some sort of special powers. And those two special powers are right here. These are two special limits that you need to memorize. I will say that again. You need these memorized. You need to take time to memorize these two trig limits. And you need to memorize all the parts, right? They both only apply when x is approaching 0. I'm going to clarify that a little bit in the next video, but for right now, when x approaches 0 and you have sine x over x, that limit will be 1. Now note, this has to be an x, this has to be an x, like they have to be the same. But the idea is if you have a limit as x approaches 0 of sine x over x, that limit will be 1. I should mention, by the way, it's okay if it's actually flipped over. It's okay if it's x over sine x. And the big reason for that is if you take the reciprocal of this, you would just take the reciprocal of this, and the reciprocal of that is, of course, 1. So that's fine as well. In my opinion, this is the one that gets used most often. This one, it's important for us to know, but it's generally not used as often. So for this one, the limit as x approaches 0 of 1 minus cosine x over x, that limit is 0. Okay, so I've got a few examples where we're going to use this. We'll take a look at them now. Alright, so my first question, I want us to evaluate the limit as x approaches 0 of sine x tangent x over 3x squared. And I'm sure that this looks terrible. Like, we just have no idea what's going on. But I guess what I want to say to you is the special powers we had on the previous page, the special limits that we had on the previous page, are basically what are going to get you through these problems. So it's your job to sort of use algebra and manipulate things and move things around to try to make sine of x show up, right? So I'll take the first step in this problem and let you guys maybe pause it and try some on your own. So my first thought here is I see that there's a sine x in the top, and I see that there's an x. There's actually two x's in the bottom. There's like an x squared in the bottom. So what I can do is I can sort of move this apart. I can write, all right, well, the limit as x approaches 0. I could write the sine of x over x times. Now, if I sort of pulled out the sine x, what's left on top? Well, tangent x is left on top, right? And if I pulled one of the x's out of the bottom, there's basically a 3x on the bottom. And I don't want to do it yet, but basically this sine x over x becomes what? Well, that limit should be 1. And I'm not going to write that yet, but the idea is, hey, I've taken care of this. Now my limit, I've broken it down, and I just have to look at this. So this is where I'd like you to pause the video and sort of think for a minute, like, how can I work with tangent x? In particular, think about what tangent x is, and see how you could sort of rewrite this and rework it. So I'd be looking at this saying, all right, I have the limit as x approaches 0 of sine x over x times. Now what I'm thinking is tangent x is basically sine x over cosine x, and this is all over 3x. Now somehow I need, so again, I'm sort of looking at this going, I see a sine x, I see an x, maybe I can do the same kind of trick. Maybe I can sort of pull out a sine x over x and just sort of see what's left. So again, the question I would pose to you is how do I simplify this? How do I work with this compound fraction? And the answer is we should multiply the top and the bottom both by cosine x. That's a messed up x. Cosine x. And a cosine x on the bottom as well. So when I do that here, these things are going to sort of eliminate with one another. Let's sort of rewrite and see what we have. The limit as x approaches 0. I have my sine x over x, and I'm sort of keeping this quarantined over here because I already know it's fine. In the next part, I have sine x over 3x cosine x. So, again, I'm going to pause the video, sort of think about how you could sort of do the same trick that I did before and separate this into pieces. We should be able to do the limit as x approaches 0 of still my quarantined sine x over x times. Now here, I'm going to pull out the sine x over x, and what's left for this last fraction piece? Well, there's effectively only 1 left on top, and on the bottom there's 3 cosine x left, right? And so now I can use my properties of limits to say, oh, I just have to evaluate this part of the limit times this part of the limit times this part of the limit, right? This first red part of the limit is 1, because that's one of my special limits, times my next part of my limit, this is another special limit, it's times 1. And then finally my last part, I have 1 over 3 cosine x. For that one, it's not a special limit, but the way I handle every limit problem, and you're going to hear me say this again and again and again, is we attempt to evaluate this expression for this value. What happens when I attempt to evaluate for 0? I get 1 over 3 times the cosine of 0, and hopefully you remember your unit circle. Cosine of 0 is 1, so this is basically 1/3. So for this limit, I have 1 times 1 times 1/3. Therefore, this trig limit is 1/3. Okay. This problem was sort of on the harder end of the spectrum. The ones that you'll have in the assignment are a little bit easier, and some may be more complicated. But this is the idea. The idea is you want to take your original expression and sort of find ways to make these special limits show up. Each time you do that, what's left gets simpler and simpler until you can actually solve the problem. So here I have another example for us. Evaluate the limit as x approaches 0 of the cotangent of x minus cosecant of x over 2x cosecant x. This is one that I'd really like you guys to try on your own. So sort of pause the video, think for a minute about what these things are, maybe take a first step or two, and then sort of watch me take a step and see if they match. If not, sort of readjust and try again. So a lot of times in these problems it makes sense to take I'll call them the weird trig functions, cotangent, cosecant, secant, and tangent, change them into sine and cosine. Our special limits only have sine and cosine in them, so it often makes sense for us to sort of rewrite them in terms of those things. So I'm going to go through and write this. I'll have the limit as x approaches 0. Cotangent is cosine x over sine x, minus cosecant x is 1 over sine x, over 2x over sine x. And as you do this, you're sort of asking, like, why am I doing this? This is making this problem so much worse. And yet, doing this allows you to see something that would be really, really nice in this problem. In fact, if you didn't pause before, or if you didn't have this idea, think about what one step you could take here that would amazingly simplify the problem. The answer is, if I were to multiply both the numerator and the denominator by sine x, like, take a look at how nice this becomes. Right? When you distribute the sine x through the numerator, it eliminates both of these sine x's. When you multiply to the bottom, it eliminates that sine x as well. It turns out all I have left in this problem is the limit as x approaches 0 of cosine x minus 1 over 2x. And I don't know about you, but this is nice, especially if you're aware of the special limits that we had before. And this doesn't look quite right. I mean, if you think about it, the things on the top are in the wrong order, and there's a 2 on the bottom. But think about what we did in the previous example, and think about what we could do here to sort of bring these things together and make it work. Right? What we're going to do is we're going to say, okay, well, I still have my limit. What I could do is I could factor the negative out of the top. I could pull out a negative and get 1 minus cosine x. Right? And in the denominator, we could do that trick where we pull apart the 2 and the x. What I'm going to do is I'm going to sort of save that for my next step. I'll write this as the limit as x approaches 0 of negative 1/2 times 1 minus cosine x over x. Right? And at this point, and I hope you guys see here where that sort of came together. Most of the time you guys are used to seeing this and simplifying it to this. In calculus, lots of times it's our job to unsimplify things so that we can see the component pieces and then work with them. Right? Now this is just an application of the constant multiple rule. We have negative 1/2 times this thing, but our special limits tell us that this limit is 0. So I effectively have negative 1/2 times 0. It means that this limit, this thing that we've been working on, is 0. Okay. So these have been some examples of some, I suppose, fairly straightforward trig limits. What we're going to be going into in the next video is a little bit more complicated, so just be ready for that.